Hi, everybody. Happy St. Patrick's Day. I am going to post a solution to one of the questions that was asked about on the forum. There was a lot of lively discussion about this one. Find the derivative of the function. So some solutions have already been posted, and that's fantastic. I'm really glad you guys are using the forum. But I wanted to just take a moment and sort of show you how I would have done the algebra also, in case that's enlightening or helpful for you guys, since there was definitely some interest in seeing the solution even after solutions were posted. So find the derivative of this function. My version was the arctangent of the square root of 1 plus x over 1 minus x, but that is different. Those red plus and minus signs vary. So in some versions of the problem, it may be 1 minus x over 1 plus x. So be mindful of that if you watch this video and then go try to solve the problem on your own in WebAssign. All right, so we want to find the derivative of this function. We need to use the chain rule because first we have the arctan as the function on the outside and the square root of 1 plus x over 1 minus x as the function on the inside. So the chain rule says we use the derivative of arctan, which is 1 plus the argument squared. And then we use the chain rule. So instead of just writing an x down there, we're going to plug in the argument of the arctan function, namely the square root of 1 plus x divided by 1 minus x. And then we will also multiply by the derivative of that function, the square root of it, 1 plus x divided by 1 minus x. Great. So now we want to take the derivative of that. And as noted in the forums, there are a few different ways to view this. One way is to recognize that the square root of 1 plus x over 1 minus x is equal to the square root of 1 plus x divided by the square root of 1 minus x. And then you can use the quotient rule and eventually the chain rule on each of the square roots. Personally, I'd like to view this as a chain rule first, thinking of the square root function as the outside function and the fraction as the inside function. Either way is perfectly valid. So let's observe in our simplification of the next line that the square of the square root just leaves you with the thing on the inside, 1 plus x over 1 minus x. And now the derivative here is going to give us a 1/2 times 1 plus x over 1 minus x raised to the power of negative 1/2. And finally, we will multiply by the derivative of that fraction, 1 plus x over 1 minus x, which will require the quotient rule. So the next line, 1 over 1 plus 1 plus x over 1 minus x times 1/2 times the fraction 1 plus x over 1 minus x, all raised to the power negative 1/2, times, and now the quotient rule says we go low d high. That's 1 minus x times the derivative of the top is just a 1, minus high d low, it's 1 plus x times the derivative of the bottom, which is minus 1, square the bottom, and away we go, leaving us with a 1 minus x quantity squared in the denominator. Great, so now we have accomplished all of the derivatives that we needed to compute, but we have this kind of messy looking thing, and the request in the forums was specifically to look at the algebra of simplification of a problem like this, which will become increasingly important as we move through the rest of the semester. So let's consider how we might want to deal with this. One thing that I would like to do personally is recognize that each of these things I'm multiplying is a fraction. So maybe I could just write this all as one big fraction. This exponent here is negative, so I could replace that with a positive exponent at the cost of taking the reciprocal of the thing on the inside. And this expression here can be simplified if we just actually add and subtract. So we need to make sure that we keep it as a factor once we've simplified it, but it will simplify. So let's see how that works out. On the top of this fraction, we've got a 1 and a 1, And now remember, this negative 1/2 exponent means that I want the reciprocal. So we'll end up with a 1 minus x to the power 1/2 on top. And then over here, when I look at this 1 minus x times 1, I just get 1 minus x. And then minus negative 1 times 1 plus x. That should just give us a plus 1 and a plus x. And we'll notice that that minus x and that plus x are going to cancel with one another, which is great. All right, now in the denominator, what do we have? Well, we've still got this weird funky sum. We've got 1 plus the fraction 1 plus x divided by 1 minus x. That is one of the factors. We've got another factor of 2, which I'm going to opt to write in front, just because that's a nice place for constant factors to go. Now this negative exponent is going to make 1 plus x to the power 1/2 sit in the denominator. And finally, we've got this last term, 1 minus x quantity squared. All right, that's a little bit better, but as we noted, that minus x and the plus x are going to cancel, leaving us with just a 2. So that 2 is going to cancel with the 2 in the denominator. And also, let's observe now that this term right here, that 1 minus x squared, well, it's being multiplied by this. All 4 of these terms are being multiplied together. So in particular, I could think of it as just being next to this expression here. And if I were to distribute that factor across this sum, then I would get some cancellation and I would get rid of that 1 minus x term in the denominator of the fraction inside of our larger denominator. So let's see how that actually plays out. We've got this whole fraction is going to be 1 minus x to the 1/2. 1 minus x plus 1 plus x leaves us with a 2, which I'll write in front. And we've got this 2 down here. When we distribute the 1 minus x squared, we should get a 1 minus x squared, because we multiplied it by 1. And then we should get a 1 plus x times a 1 minus x, since one of the 1 minus x's in 1 minus x squared cancels with the 1 minus x in the denominator, and the other one gets multiplied by that numerator. Finally, we have this last term, 1 plus x, all raised to the 1/2. Right. So we'll see that these 2's are definitely going to cancel now, but also that expression there and that expression there, if we were to multiply things out, we're going to end up with a negative x squared and a positive x squared, and those will cancel as well. So it really is worth taking this next step. We'll see how nicely things end up simplifying. Canceling the 2's, we just have a 1 minus x raised to the power 1/2. In the denominator, we're going to write 1 minus 2x plus x squared, coming from that 1 minus x quantity squared above. And then we're going to have a 1 and a minus x squared, coming from the 1 plus x times 1 minus x below. Now that whole sum is still being multiplied by 1 plus x to the power 1/2. And as I had mentioned, that x squared is going to cancel nicely with that minus x squared, leaving us with 1 minus x to the power 1/2 divided by 2 minus 2x times the quantity 1 plus x to the power 1/2. All right, that is definitely better than what we started with. But finally, there's one more thing that we can do, which is to note that the only difference between that 2 minus 2x and that 1 minus x is a factor of 2. And so if we factored that 2 out, we would have 1 minus x to the power 1/2 divided by 2 times 1 minus x to the first times 1 plus x to the power 1/2. And now that 1 minus x to the half and that 1 minus x to the first, well, we can subtract exponents if you'd like, or rather, I'm going to cancel the 1/2 in the top with 1/2 of a power in the bottom. And we'll end with 1 over 2 times 1 minus x to the 1/2 times 1 plus x to the 1/2, which I think looks very nice and symmetric and is a great expression to end with, which is, I think, pretty obviously much nicer than this thing we got after we finished doing the derivatives here. So that is how I would do the simplification. Let me just observe, of course, that there are several different ways of writing this same expression. You might write it as 2 times the quantity 1 minus x times 1 plus x, all raised to the 1/2. Or you might prefer to write it with square roots instead. Square root of 1 minus x times the square root of 1 plus x. Or you might combine those all into one square root as well. Square root of 1 minus x times 1 plus x. Any of those are valid. They're really just small notational differences on the same thing. This is the simplification that I would do, and hopefully you guys have found this helpful.